Let's do a few examples here. When Mr. Smith kicks a football, it has a vertical speed of 20 meters per second, and its height, h in meters after t seconds, can be modeled by the equation h is equal to 20t minus 5t squared. Draw a rough sketch of what you know so far. So just to clarify, the h here is not representing the h as in axis of symmetry or the x coordinate of the vertex. The h here has been defined as the height of the football, and t is the seconds. Now let's start there. H and t are the x and y's. So instead of x and y, we have t and h, where t is equal to the time and h is equal to the height. So if we start with our axes here, I could label my x-axis as in time and the y-axis as in height. Another thing I know based on the equation is that I have a negative a value. So this parabola is going to open down. Also, I notice that this is in standard form and there is no c term. So that means it will pass through the origin for sure. Okay, so as a rough sketch for this parabola, we're probably going to have something that goes up and then comes back down. So what's the maximum height of the ball? When does it get to the maximum height? We are looking for the vertex. But now, finding the vertex, you have a number of tools that you know how to use to find the vertex. So at this point, it's about choose your own adventure. How would you like to find the vertex? We could complete the square to put it into vertex form. We could use the equation h is equal to negative b over 2a, or we could factor and use the midpoint to get back to the vertex. Your choice. Right now, I'm going to use h is equal to negative b over 2a. So we have b as in 20 over negative 2 times negative 5. Now be really careful here because the original equation isn't in the ax squared plus bx plus c form. The a term came after the b term. Okay, so let's expand this. We have h is equal to negative 20 over positive 10, and we have 2. Okay, so I know right now that at 2, we're going to have the vertex. So we can already answer the second question. When does it reach the maximum height? We reach the maximum height at 2 seconds. Now, for us to find the k, or the y coordinate, we're going to substitute this back into the h equation, or the original. So let me distinguish that this h we're talking about is the axis of symmetry h. H equation now that I'm going to substitute it into is the original. So 20 times 2 minus 5 times 2 squared. So h original is equal to 40 minus 20, and we have a height of 20. Our vertex, 220. So this answers the question, what's the maximum height of the ball? Maximum height is 20 meters. When does it reach the maximum height? It reaches it at 2 seconds. Next part, how long is the football in the air? Well, we know that the x-coordinate is time, so we're looking for the x-intercept. I know that one x-intercept is at 0, 0. The next x-intercept we're going to do is to factor or put it into the quadratic equation. I'd like to factor, so I'm going to factor out a negative 5t, and we would have negative 4 plus t. So when h is equal to 0, we're going to have first option where negative 5t is equal to 0 and t is equal to 0. Our second option is when our second bracket, negative 4 plus t, is equal to 0. And when we rearrange it, we have t is equal to 4. Okay, so that tells us here my x-intercept. I have a 0, 0, and the other x-intercept is at 4, 0. So how long is the football in the air? It was up in the air for 4 seconds. Now the last question here. How long after it was kicked that the football is at a height of 15 meters? 15 meters, probably about here. So it's like we are looking for this imaginary line to see at what point it crosses this imaginary line. We already know what the h is, so I just need to find my t value now. Let's put this into the equation. So I have 15 is equal to positive 20t squared minus 5t squared. And I got that from the original equation here. I'm going to rearrange this so that it is in standard form. 20t squared minus 5t minus 15 is equal to 0. I could substitute this into the quadratic equation, or I could factor it. I'm going to try to factor it first because factoring is faster than using the quadratic formula. And simplified, we have 5 times Oops, I have made a mistake. Let's put this 15 into the equation. Here's our original equation, and the h will now be 15. 15 is equal to 20t minus 5t squared. Let's rearrange this so that it's in standard form. 5t squared minus 20t plus 15 is equal to 0. I'm going to factor out the 5 to see if I can factor this trinomial. Usually factoring the trinomial is easier than using the quadratic formula. So if I can, I'll factor. Okay, so we have 5 bracket t squared minus 4t plus 3. This is a trinomial that is factorable, and we have the first t is equal to 3, the second t is equal to 1. So when we come back here, we know that at 1 second and at 3 seconds, we are going to be at 15. So the coordinate 1 and 15, 3 and 15. Okay, one more example. A ball is thrown vertically upward in the air from the top of the cliff. Its height above the ground is approximated by the relation h is equal to negative 4t squared plus 38t plus 80, where h is the height in meters above the ground and t is the time in seconds. Draw a rough sketch of what you know so far. Okay, one thing I do know so far is that we, again, don't have x and y. We're using the variables h and t. T is representing the time, and h is representing our height. I know that the x-intercept is 0, or sorry, the y-intercept is 0 and 80, because this is the c in standard form. I also know that this is going to be a parabola that opens down. Let's draw a quick sketch of this. So at 80, the ball starts to be thrown. It's going to probably go up and then land somewhere on the ground. First, let's find the zeros of the relationship. When we're talking about zeros, we're looking for the x-intercept. I'm going to factor first again to see if I am able to factor it before I use the quadratic formula. So doing my common factoring, I have t squared minus 8t minus 20. This becomes t minus 10, t plus 2. And the height at the x-intercept is equal to 0. So we have t is equal to positive 10 and a second t at negative 2. But we can say that negative 2 is inadmissible. What that means is we're not going to take that into consideration because we know that time, being the x-axis, is not possible for us to have a negative value. So we're going to throw out the negative 2 and only keep the 10. Now what this tells us is it tells us when it lands. At 10 seconds, the ball lands on the ground. Find the coordinates of the vertex. Well, since I've already gotten the two x values, even though one is inadmissible, I am able to use both of those values to help me find the midpoint. Let's use the midpoint equation. I have 10 plus negative 2 divided by 2. Midpoint is equal to 8 divided by 2, or 4. So we know the vertex happens somewhere where there's t is equal to 4. I'm going to substitute this back into our equation And you could substitute it into any form you like. I actually think substituting it into the factored form might be easier right now. I'll do that. -4 times 4 minus 10 times 4 plus 2. H is equal to -4 times -6 times 2. H is equal to 144. So what that tells us, maximum height is at 144 meters, and it's reached after 4 seconds after release.